Today's topic is ethics and the future of intelligence. Basically, I want to look at ethical issues that come up as we project AI development into the future. Questions concerning the development of future AIs and the sort of things that we might be able to do once we have actually developed those technologies further. So the timeline is that I want to talk from now until about 1 o'clock. We'll have a usual 5-minute break and then resume the lecture and talk for the rest of the time. In that time, I want to talk you through 4 questions that I think sort of is one way of breaking down this discussion. So the first question is, can society build a super intelligent AI system? And early on in the lecture, we'll talk about what that means, a super intelligent AI system. But this can question is like a technical question. So we won't so much be talking about ethics yet. Similarly with this section one, this second question, what if society builds a super intelligent AI system? This is a chance to reflect on what the sort of impact or consequences might be from a technical perspective, or sort of trying to use our understanding of the world to project what might happen. And that's also not going to be a ethical question. And then when we get to question number 3, should society build a super intelligent AI system? That word should brings in the ethical evaluation. And so I'm going to try and break this question down with reference to our ethical frameworks that we've used, that we've learned about this semester, utilitarianism, deontology, and virtue ethics, and try to see if they give us any insights into how to cope with the sort of choices that we might have to make as a part of building a super intelligent AI system. Finally, the 4th question is, will society build a super intelligent AI system? This 4th question is not, as phrased, it's not necessarily an ethical question either, but I want to use this as an opportunity to sort of look at the sort of current landscape of people that are trying to build advanced AI systems and ethical questions that arise when we're thinking about how to organize those efforts and how to coordinate them. And as Simon said, this lecture is not examinable. I hope this means that you can use this as a chance to sort of relax and listen, ask lots of questions, without worrying too much about taking notes or making sure that you're sort of getting every point on the slides. Hopefully this sort of means the pressure is off. Okay, one more thing before we start the lecture is that I do feel the need to warn you about some of the topics that we might be discussing. Not to sort of overdo this, but in this lecture I want to take seriously some certain possibilities, including very negative outcomes that might arise in the future, including global catastrophe or human extinction from AI. And there's sort of an undercurrent of, well, it might be possible that even if that was true and we wanted to stop it, there might be sort of nothing we could do because there are sort of powerful forces that are pushing for that to happen. And when I was thinking about this, for me it feels a bit like thinking about climate change, which is, you know, a very difficult problem facing the world. And especially as young people, when we look at that and how this might be something very challenging that might happen in the future, that can raise some very difficult feelings. I think it's worth having the discussion today in spite of this sort of danger, but I don't want this to cause you distress. And so I want to make this clear right now. And also point you towards some resources that the university has made available to support you if you're feeling difficult feelings from this kind of topic. So very briefly, these are that there is a free self-directed LMS module called the Sustainable Self that you can enroll in. You can enroll in this module at any point and go through it at your own pace. The idea of this module is that it gives you skills to sort of cope with difficult feelings that arise from sort of topics that you're studying throughout your studies. For more personalized sort of advice, you can book a free counseling appointment from the university's counseling and psychological services team. And even though this is their peak period of the semester, they're still able to offer appointments if you book early in the morning, later the same day, or the following day. And third, if you are facing, in your personal situation, any acute mental health crisis situations, the university also has a mental health crisis support service to offer support whenever you need it 24/7. And there are other crisis support listed services listed on their website. So, without further ado, I'd like to begin the lecture. So I said we're going to talk about these 4 questions. The first question being, can society build a super intelligent AI system? This is our opportunity to discuss what this term means and how likely, technically, this is to be possible. So, first I want to draw a distinction to so-called narrow AI, or narrow artificial intelligence. This is a descriptor that applies to most of today's AI systems, which have these two properties. They're designed to perform a single task, and maybe they perform that task very well, possibly even better than any human can perform that task. However, it doesn't really make sense to, say, use that system to try and perform some other task. It's purpose-built. And part of this is that it operates in a highly restricted setting, and you have to sort of specially prepare the inputs and specially process the outputs in order to get use out of this system. So some examples would be systems that we have studied in the semester already, such as image classifiers and facial recognition systems. Automated decision-making systems that are more and more pervading many institutions in the world, such as in finance, law, and medicine. And in academic AI, sort of pushing the capabilities of these narrow systems, we've had breakthroughs over the last decade in making progress in AI systems that can play competitive and challenging board games beyond the limits of the best humans, and also video games, not just board games. You could describe the story of AI so far from its origins in the 1950s or so, and obviously going back earlier as well, as a story of designing one narrow system after another that can cope with more and more complex tasks. And so there was a point where we were using symbolic AI systems. We talked about the history earlier in this subject, the history of AI. There was a point where we were using sort of symbolic AI systems that could handle certain tasks, such as playing chess. Eventually, we ended up with Deep Blue being able to beat the world champion in chess. After that, it took a breakthrough in learning systems to be able to make progress enough to beat the world champions in the game of Go, a much more complex, computationally and sort of strategically complex game. We've continued to make progress in this direction, and people in the field are working on sort of new problems all the time that they can try and add to this list of things that they can handle. But in each case, we're designing a specific AI system for each task that we want to accomplish. So this raises the question, what about one AI system that could handle multiple tasks? Broadly speaking, that's what's been described as general artificial intelligence, or artificial general intelligence, abbreviated AGI. So such a system, it's debatable, but most people would say doesn't quite exist yet today, but we can imagine, as an extrapolation of the previous type of system, a system that is capable of performing a broad range of tasks to human-level performance, and this breadth is the difference. Instead of one narrow task, this one system is able to perform the same sort of breadth of task as a human can perform. So you can take a human and you can say, all right, I'm going to put you in a cafe and you're going to have to learn how to use this coffee machine, and then they're going to be able to do it. Or I'm going to put you in a university and you're going to have to learn how to do calculus, and they'll be able to do it. And then you're going to end up with one person, one human, that can do multiple tasks, everything from coffee to calculus. Another distinguishing feature of a general intelligence is that it would have to be able to operate in a slightly more flexible input sort of a situation. The real world is like this. There's many sort of modalities of inputs and outputs around us. Even a complex virtual world such as sort of open-ended access to the internet would need this kind of more flexible inputs than we currently have. So it's debatable, I said, whether this has been achieved, and that's because some people might claim that recent breakthroughs in language modeling, particularly large language models such as ChatGPT and the very many sort of similar systems that are around over the last couple of years, these systems can actually perform quite a large range of tasks, having been trained on quite a diverse data set with machine learning techniques. And I would say that my experience engaging with these systems, they have this sort of superhuman breadth of intuitions. They know everything from history to politics to technical stuff like physics and machine learning. It's rare to find people that have that breadth of intuition. So this is something that is actually superhumanly broad about them. However, they don't have the same robust and sort of focused attention and performance capabilities as a human. So some people say that they haven't really reached human-level performance in important tasks that humans can do effortlessly. Also about the environment, it's not super open-ended, although they can handle many inputs in linguistic form. In order to be able to use an LLM on a new data set, you actually need to be able to train embeddings to be able to sort of get that into the model and able to do anything with that. So for example, when you want to have a large language model that you can use on images, which is now obviously possible, we've seen many examples of this, you need to do some computer vision to be able to translate that into the format that the LLM will accept. It's amazing that you can do that, and there aren't that many modes, once you do language, vision, there aren't that many other things. Maybe we could eventually get to a point where this was flexible enough to be called general. That wouldn't be too surprising. So the question is now, is it possible to get from where we are now in the future to AGI? So a couple of people have different opinions on whether or not this is possible, and I've sketched some potential paths that people put forward to actually achieving AGI. One school of thought is that we're actually pretty close already, and current techniques such as the machine learning techniques that go into building large language models, if we scale these up with more data and larger systems, we'll be able to get to AGI. And it's just actually these systems, the limitations that they currently display are not fundamental. They'll go away with more training and more scale. Some people think that, and some people think that actually, no, these systems do have fundamental limitations. We're not going to because this is not a machine learning class, I don't think we should get into the debate there. But even if this wasn't possible, the question is AGI possible? Not is AGI possible with current techniques? And so there might be other ways that we could get to AGI. People sometimes point to the human brain as a proof of concept of general intelligence. I think that's easy to accept. And then they make the argument that, well, if it's possible for the human to implement general intelligence, it should be possible, for example, by very closely mimicking the way that the human does that in a machine, it should be possible for a machine to implement general intelligence. So for example, Nick Bostrom, a futurist and philosopher from the University of Oxford, has, in his book Superintelligence, which I listed as one of the many optional readings this week, Nick Bostrom has studied what it would actually take to do a neuron-by-neuron implementation of the human brain in a machine. And the reasoning being that there's actually nothing other than that going on in a human brain. This is sort of a thesis that the human brain is sort of a mechanical system that is responsible for all of our general intelligence. If you could just implement that in a precise enough level of detail, you would then be able to simulate a human brain in a machine, therefore AGI. A third path that has been proposed is that rather than taking humans as the proof of concept, take as the proof of concept that evolution over the history of the human species has created from nothing a general intelligence. And maybe if we simulated evolution in a complex, open-ended environment with any sort of non-trivial reward function, which is just sort of something you optimize, like in terms of evolution, we're talking about inclusive genetic fitness and just survival. And if you put enough brute force trial and error into this, like the billions of years of evolution, you might end up with something intelligent. This would be what I would call the reward is enough hypothesis, that intelligence is sort of just emerges when you have these other conditions and enough brute force. This is a controversial hypothesis, or at least the people who put forward this reward is enough hypothesis, including Richard Sutton, have been sort of criticized for missing important details and so on. But if you think of it in terms of an analogy to human evolution, I don't think it's that controversial. Although, of course, it's a big question whether or not we would actually ever be able to amass such energy to actually carry out this process, sort of repeat evolution. And maybe, actually, we were quite lucky in sort of getting to where we are in our case of evolution, and that might not be the case if we were to just run this again. So, yeah, there's a lot of uncertainty there. Much of the debate actually focuses on, however, how close we are to AGI, rather than whether or not it's possible to build AGI. So this is not something that we're going to get into today in terms of timelines. There's a lot more uncertainty there. But I think that the ethical questions that might arise if AGI was possible are important, or we can discuss them, whether or not this is 5 years in the future, 50 years, 500 years. It still makes sense perhaps to cast our eyes forward and think about whether there will be any ethical dilemmas that arise. Final note here is just to mention that, of course, people in AI research are the ones who think generally and generally agree that AGI is possible. However, that might be a biased selection of people because they've decided to dedicate themselves. This is like a long-standing goal of the field to build this AGI. And so if you don't think it was possible, I'm not sure why you would be in the field of building AGI. And also, we've sort of had in the history of AI many situations where we've come up against problems that we actually find out it's more difficult than we thought, and we have to come up with a new approach. So that brings us to the main topic of today's lecture, superhuman artificial intelligence, also called superintelligence, or ASI, artificial superintelligence. So the question is, let's say we think AGI is possible. Why would the human level performance and breadth be the limit of performance and breadth? Bostrom has defined a superintelligence as any intellect that greatly exceeds the cognitive performance of humans in virtually all domains of interest. So this is sort of basically saying, imagine AGI, but way smarter. It's a little bit difficult to analogize this because, or to understand this, there are certainly no examples of this that I can point to. However, I can offer some analogies that can help you to sort of think about what I'm talking about here in terms of way smarter than an individual human. First of all, this means that you can imagine the most intelligent human in any domain, be it maths or physics or computer science or other domains, which I'll talk about in a moment. Imagine something that was at least as smart as them all combined. So the world's leading researchers in every field, the world's leading performers in every other domain, all in one. Also, I think we have this intuition that society or people working together can be more powerful than an individual. And so this is another thing you can use to try and imagine what a superintelligence could be like, or the direction that a superintelligence could be like. If you consider what you can do as an individual versus what a large corporation, such as Google or something like that, is capable of achieving and building with their combined intellect, I think you see a contrast there. And so you could imagine that a superintelligent AI system might be similarly more powerful than even all of humanity's collective efforts put together. Although this analogy is sort of, I have to mention that whenever you group people together, there becomes like these communication overheads and stuff like that. So not necessarily going to have an unbounded increase of intelligence through this analogy, but at least you get the idea that we could have something more intelligent even than a lot of people working together. I said before that the examples of domains that I used was physics and mathematics. When we're at university, these are the kind of things that we sometimes think about as capturing intelligence. However, there's more to intelligence than just sort of nerdy, smart people intelligence. That's one sort of stereotype of intelligence. But non-intellectual domains, such as motor control or sort of dexterity, this is sort of something that your brain does. Social intelligence and emotional intelligence, having a good intuition and being able to read people, is something that requires cognitive processing. And there's no reason to believe that an AI system couldn't, in principle, be better at that than the best humans. Creativity, leadership, rhetoric. Imagine someone that is superhumanly persuasive, knows exactly what to say to make you think something. This is the kind of capabilities that might be sort of in scope for this hypothetical superintelligent intellect. Another idea is that often thinking about distribution of intelligence is confined to an sort of human scale, where we have very intelligent humans like Albert Einstein or something, and very unintelligent humans. A village idiot prototype is something that authors in this field have used as an example. Perhaps the scale here is misleading, and what we should be thinking about is instead the difference between a typical human, any human, even a village idiot or Einstein, doesn't matter. That difference is actually small compared to the intelligence of an insect. And then in order to imagine superintelligence, you can try and imagine, well, what if we were the insect and the superintelligence was humans in comparison? So I want to talk about whether or not this form of intelligence, vastly more intelligent than AGI, is possible. In this case, I want to assume that AGI is possible. It seems that if AGI is impossible from the previous arguments, then there's no way superintelligence would be possible. But the thing is, if AGI is possible, then it seems to me that we would be able to continue increasing intelligence using the same techniques as we have been using to create the AGI in the first place. So superintelligence might follow naturally from AGI. Some different ways that you can see this is that once you have an AGI, it would probably be possible to speed it up by making faster hardware to run your machines on, run their computation faster. So that can enable an increased intelligence, because imagine, for example, the difference between a timed closed book exam and a take-home exam where you have a month. I imagine that you can see that in the case of a take-home exam, you can get a better mark because you have more time to think, process, research. And so what if an AI is playing a game of chess or Go or any other game or something like that, and you give it unlimited time to process? Well, we don't actually have to give it unlimited time if we can just speed it up. You can imagine that it might be able to perform better. Quantity. We already talked a little bit about how populations of humans can exceed the capabilities of individuals, taking this performance hit from sort of communication overheads into account. Maybe this is the case also for AGIs. We would be able to replicate them, assuming we could find enough hardware, and create groups of AGIs, and then combine them into a more intelligent, potentially super intelligent system. It's a little bit harder to imagine qualitative improvements because we don't really have a reference or examples for this. But it seems possible that there might be fundamentally better than human cognitive approaches, and we might stumble upon these while searching for AGI. In order to think about this, one example that I find helpful is humans have dedicated modules, neuroscience tells us, for things like linguistic processing, so language, visual processing, spatial reasoning. And in order to do other things, sometimes we actually bootstrap on these. So in order to do reasoning, we sort of make use of our linguistic and our spatial sort of systems. But you can imagine that it might be possible to create a system that is sort of specially purposed for, I don't know, four-dimensional spatial reasoning or mathematical logic or something like that. And if we had such a thing in a cognitive architecture of an AGI, there's no reason why that couldn't enable it to become arbitrarily good in comparison to humans in that domain. And finally, people talk about recursive self-improvement when they talk about AGI. This is the idea that after we achieve AGI, progress might begin accelerating because the building of AI systems is an activity that presumably the AGIs, seeing as they're generally intelligent, would be capable of contributing to. And then they would be capable of making themselves smarter, basically. And then once they're smarter, they would be even better at making themselves smarter. So the question, rather than sort of like how intelligent would the first system be, would be what is the new equilibrium of intelligence that is enabled by research into improving the design of these systems. There's this thing that, so evolutionarily, humans have, our given amount of intelligence. Presumably, it would have been more helpful for us to be more intelligent, so evolution would have made us more intelligent if it could have. And so we might be at some kind of equilibrium. But you have to remember that in the case of humans, the intelligence that we have is sort of a trade-off between other factors. For example, maybe we could have had much larger heads and brains. However, they would have cost more energy, and actually, in the case of human sort of skull size, it would have become much more difficult to give birth to a human child if it had to have a larger head. And so it would have become more painful for women to give birth, and you would have had to sort of solve a logistical problem. So evolution might be stuck for sort of reasons that don't apply to AGIs. We don't have to be birthed in the same way. We could create an arbitrarily large artificial brain, for example, because we sort of build it in a lab. A final note in terms of can we build artificial superintelligence is I want to draw a distinction between intelligence and consciousness. Sometimes people ask a different question, which is, can society build an AI system that is conscious? And by conscious here, I mean it has a subjective experience. it's something that it likes to be, something that it is like to be that thing from an internal perspective. This is something that humans have. It's not clear if any other things have it because we don't really understand consciousness, even in the case of humans. And so the connection to AGI and superintelligence is uncertain. And I would point out to you that, okay, yeah, it may be possible to create a general or superhuman AI system without creating a conscious AI system. This is something that philosophers of mind study, and there are arguments such as the famous Chinese room argument, where you have an example of an information processing system that is argued to be completely unconscious, even though it behaves intelligently. For example, it solves the Turing test. Or perhaps it is actually, if we were to create an AGI or an artificial superintelligence, it would sort of naturally be conscious, and whatever we did to make it, for the same reason that we are conscious, it would also be conscious. We don't know the answer to this question. This is completely depends on what is it that causes consciousness, and we have sort of not very clear ideas about that as a society. But 2 points. One, creating consciousness may not require understanding consciousness. This is the case whenever anyone gives birth to a human child. That child eventually becomes a conscious adult, who everyone would agree is conscious and has an internal subjective experience. But we did this without having a model of what was going on. And it's possible that if we were going to create consciousness, that the same thing could happen kind of without intending it, or by accident, or without realizing. So the point is that it sort of has no bearing on how intelligent this system is, with the sort of definitions that I've given so far, whether or not it's conscious. And so from a technical perspective, the possibility of building consciousness, it's nothing to do with whether we understand consciousness or if consciousness is even possible in such a machine. We're just talking about its behavior, basically, external experience rather than internal experience. This does matter from an ethical perspective, because some people ground ethics in things like subjective experience. For example, a utilitarianism variance concerned with pleasure and pain, presumably that's pleasure and pain for some consciousness. And if the machine isn't conscious, then we can subject it to anything that would be sort of painful, and we don't have to worry about rewarding it with anything that would be pleasurable. However, if it is conscious, then we have to incorporate that into our calculation. So this can matter a lot, but not from a technical perspective. So we'll come back to that later. Question?
Would you say that the memory mode in tools like ChatGPT counts as some form of consciousness, or maybe halfway to it?
I completely refuse to engage with any such discussion because I have no idea. I'm sorry. The question was, is there some sense in which part of ChatGPT, when the memory is turned on, is conscious? And I don't know. I think it's appropriate to say that we really don't understand what's going on there at all. There are models of sort of conscious experience that people in the philosophy of mind and neuroscience talk about. I'm not really familiar with them. Maybe some of them will give you some kind of answer, but as far as I understand, there's no consensus on this. Were there other questions? Yes?
I was just thinking, isn't this a bit too optimistic? Because we still don't know, only deep learning models we know is a single neuron kind of technology like AlphaGo chess. But say if you're building AGI, it's going to be the multi-neuron technology, right? But we don't even understand the neuron transmitter or how synapses connect together. So how do we know if this is going to look?
So I'm not quite sure I understood your question. I'll see if I can restate the sort of core part of it. Is that in deep learning we use simplistic models of neurons that are kind of quite divorced from natural neurons in biological neural networks like the brain. So wouldn't we need to take care of that difference before we ended up with AGI? Is that your question?
I feel like we need to study brain more before we do AGI.
I think that we might need to study neuroscience more before we can make it to AGI. That might be very well possible. Yeah.
Can I point out that? So that is only if we're following the second approach you outlined in the previous slide, where we have to replicate a whole brain. It's possible that through developing just by scaling up kind of systems we could get there, or by developing a artificial evolutionary landscape, maybe we could get into such systems. Does that answer the question?
Let's say that again.
I think what you're saying is it's corresponding to the second approach, the whole brain relation. But it's possible we could, if I'm not mistaken, get to AGI by the other two routes, possibly?
Yeah, whole brain emulation would certainly involve more detailed models of neurons than we currently have. But it is true that I think that it's conceivable that these details of the neurons are not actually fundamental to the intelligence. They are if we want to build intelligences like the brain. And there is probably still much to learn from the brain if we're using other approaches, and there are many people that work at the intersection of neuroscience and artificial intelligence, and they're working on these kind of things.
That book at ETH was doing exactly this.
Yeah. Stuart and I have been to ETH Zurich, where their researcher, Matt Cook, works on models of neuroscience to inform AI. Any other questions?
Just, if you don't mind me asking, just, I'm not as of your professional opinion or anything, but just, what do you currently intuitively perhaps feel about the first scenario?
What's my opinion on the first scenario? We're nearly there. Yeah, okay. I mean, I haven't sort of comprehensively researched the evidence here, but I would not be surprised if actually there's not that much more complicated going on in human brains than in the sort of current largest models. There are many differences. For example, human brains are much more energy efficient and can do for the same amount of output as a large language model. But I think that it might be the same fundamental principles of learning in terms of evolutionary learning, in terms of designing the architecture of the system, and sort of learning from data in terms of learning from experience from when a human is born to when they are an intelligent adult. I think that some very similar fundamental principles are at play in the way that we're currently building systems, and I wouldn't be surprised if with enough data we could get there. Yes?
Sorry, I know that we've just had a stream of questions.
That's okay.
Last
Last one.
I don't know if you're familiar with Bernardo Castro, or you're probably definitely familiar with Floridi,
Yeah.
who critique this idea of AGI or superintelligence. What's your response to them? Because it seems like you're very much on this path.
Yeah, so I should have read more Floridi. Luciano Floridi was at Oxford Internet Institute until I think recently, and he is a philosopher who also thinks about like society and technology and sort of developments. And I've seen him critique examples of existing AI systems such as language models, and point out specific things that these models are not able to do, but humans can obviously do. I think his work is broader than this, but this is the work that I'm familiar with and can comment on. Is that okay? Yeah, so this general approach of pointing to something that AI systems can't do, it's like they can't do it yet. But there's been a long history in AI, well actually a sort of a substantial recent history in AI that I can point to more specifically, of these problems kind of disappearing as we scale AI. So for example, it was a famously sort of long running thing that AI couldn't do common sense. And so Marvin Minsky, early AI researcher who worked at MIT, used to go around and say to his students, there's no AI system that I can say, well, why can't you push something with a string? You can pull something with a string, but you can't push something with a string. A human can see that it's ridiculous to try and push something with a string. It doesn't make sense at all. It's a little bit hard to articulate why, but AI systems would not be able to answer this kind of question that requires sort of general knowledge of the world and sort of how objects interact. ChatGPT can answer this question fine. And maybe that question was in the training data, I'm not sure. I think that common sense is sort of along the way to being solved much earlier than people who thought this was a fundamental barrier might have thought, because there was no specific thing we put into the systems to sort of solve this particular problem. The examples that I've seen Floridi give, and others give, not necessarily this is Floridi's sort of thing, but are the kind of things that have emerged with scale without being deliberately sort of put into the design of the system. And so the question is, what else could emerge? I think that it's appropriate to be uncertain. I don't know. That's why I say I wouldn't be surprised if these systems could turn out to reach higher levels of intelligence, including sort of human level intelligence and beyond. Okay, we should move on now. But I really welcome the questions, so I want to make sure that I'm sort of keeping on track so that we can have lots of time for questions in the other interesting parts of the lecture as well. So, the next question. What if society built a super intelligent AI system? So, a position that I think is, that I would really like to get across is that this development would be fundamentally transformative of the world. Stuart Russell who is the author of Artificial Intelligence: A Modern Approach, a famous textbook in the field of artificial intelligence that some of you may be familiar with. I didn't bring it with me today, it's a bit big. Has put in his book Human Compatible, a much smaller recent book. I don't think I brought it with me either. Everything civilization has to offer is a product of our intelligence. Later in the book he says, our intelligence is responsible for our civilization, and with access to greater intelligence, we could have greater and perhaps far better civilization. I think this is true. Intelligence has had a fundamental role to play in shaping the world, in us shaping our world to suit us. I think that's something that is also not strictly disagreeing with what Stuart Russell is saying here, but I think it's sort of changing the emphasis a little bit. Our intelligence is responsible for our situation, for our civilization, and everything civilization has to offer is a product of our intelligence, including the limitations in our intelligence. I think that if we were smarter, many things would be quite different. And so you can think of examples like the education system, which is very closely linked to human sort of intelligent capabilities. Things like our justice system and like the legal system and the way that we organize society is built around the sort of capabilities and limitations of people to be able to both act in a sort of sensible manner and also in order to be able to find disagreements and bring those forth. In a way that would be changed if we had sort of, arbitrarily capable of surveillance, for example. That would completely change the legal system. There are many other examples, such as the economy, which, the economy is a tool that you can think of. It's a tool, it's a system that solves a resource acquisition or sort of resource allocation problem, I mean to say. And one of those resources is intelligence. And so you can imagine that if there was more intelligence available, that would completely transform the economy. Other things like collaborative institutions like science, medicine, these sort of endeavors where humans get together and work together will be completely reshaped. There are many things, many specific details about them that are sort of contingent on the shape of a human and like the upper and lower bounds on their intelligence. And a general principle, so this is also came up in the talking about equilibriums of intelligence determined by evolution in the case of humans. If you remove constraints in a dynamical system, that would generally change the equilibrium that your system goes to. And removing an upper bound on intelligence is such a change, and I believe that the equilibrium could be in many new places. There's lots of reasons for optimism here, and this is a huge motivating factor in the field of AI. Imagine if we had unbounded intelligence, then we could do things that seem impossible today, like accelerating life and medical sciences, giving us very fine control over individual human physical and mental health. Things like solving illness and solving aging are on the table here. These are problems that we currently have to deal with, and we fight step by step to sort of make progress on them. But imagine if we just won that fight. Maybe that would be possible with enough intelligence. Same goes for physical sciences and engineering. We control our natural world based on our understanding of materials and our designs for building structures and so on, and machines. With enough intelligence, we could gain perhaps much greater control over the natural world and unlock control over even beyond our planet, out into the solar system and beyond. Science fiction kind of level stuff here. As for the sort of social sciences or the social sphere, a lot of social conflict comes down to difficulties in like communication and education, and this is a little bit thorny because maybe it sounds a little bit dystopian to say we could develop stable cultures and social institutions according to arbitrary chosen principles, because we have to decide like what principles are those going to be. But at least that's a nice problem to have instead of wanting things to be better and having no idea how to get there. I have here a picture of Sustainable Development Goals from the UN, and most of these, not all of them, some of them are this kind of social thing where there's lots of choices to make, would be solved if we just had more intelligence to throw at them. And yeah, I've said here, we would only have left to decide what to do with this new power. That itself is like a complex ethical topic we're not going to get into today, but at least you can think that's kind of like a good problem to have, because we can have whatever we want, we just have to decide. And ideally, we can do that in like an inclusive and sort of fair way, and that can become, the challenge. Unfortunately, there's a flip side to all of this. Maybe, actually, there would be many negative outcomes of artificial superintelligence, and we could stumble into these. So, for example, because human sort of political and economic power is currently predicated on the idea that people can add value to the economy by working, and that would be somewhat undermined by having machines that could do everything that humans could do and more. Developments in artificial general and superintelligence might lead to large-scale economic displacement and disempowerment of humans. And this could further exacerbate to an extreme degree existing inequalities and historically marginalized groups. I'm not just talking about people who are kind of downtrodden in any particular society, but globally, people that don't have access to sort of much power, such as people in the developing world. These people would be put at the complete mercy of those who maintain economic power in this new world order. AI could similarly erode social stability by undermining crucial social institutions. And we've talked a little bit in this subject already about things like deepfakes and stuff, but imagine with more intelligence, this just becomes completely an intractable problem to have anything like trust in media. We could end up with widespread automated fraud and other criminal activity, making it a horrible thing to live and try and do anything, because there's lots of things out to get you, and anyone can sort of have arbitrary power to sort of screw up your life. Also possible more dystopian scenarios talked about in science fiction, such as lock-in of authoritarian political regimes, if you think something like 1984 by George Orwell, through pervasive surveillance. Warfare could get really, really bad. It's already obviously very bad, but it could get much worse if we had autonomous weapons or newly engineered biological weapons that are specifically designed for having really bad outcomes for people. And finally, loss of control of the artificial superintelligence leading to human extinction. This is the thing that I'd like to talk about for the remainder of this topic, just to sort of expand on that one a little bit. It might seem like a very extreme claim that we could end up going extinct as a species as a result of the development of artificial superintelligence. But people take this risk seriously, including AI scientists. They take this risk seriously. I think it's worth taking seriously. This is sort of my field, is sort of investigating this risk, seeing sort of how realistic this is and what we can do about it if it's realistic. Recently, as recently as last year, to make this clear, how serious this issue is, and it's thought to be by many sort of prominent intellectuals and AI scientists, the Center for AI Safety put out a statement on AI risk, which is an open letter that's entire contents is put into this one sentence that I have on the screen. Mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks, such as pandemics and nuclear war. They were trying to say, this is something these people agree on. Instead of an open letter that has lots of claims, it's not clear if everyone signing the letter agrees with all of them. This is unambiguous. Extinction is something to worry about. Signed by hundreds of leading AI scientists and public intellectuals. And you can search it to see the list for yourself. I should add, though, some notable entries include the CEOs of DeepMind, Anthropic, and OpenAI, 3 leading AI companies, Yoshua Bengio and Jeffrey Hinton, 2 of the Turing Award winners that are known for their contributions to AI and kind of authors of the deep learning revolution. Not all 3 of the Turing Award winners. Yang LeCun is not with them in signing this letter, but I should say that not everyone in the field agrees that this is a huge problem. However, I think that the appropriate response to that is to say, well, hang on, maybe we should look into this more and find out if it's a big deal, sort of thing. So how might we actually go extinct from a superintelligent AI? The main mechanism, and I'd like to expand on this a little bit today, is loss of control followed by misalignment. However, it is time for a 5-minute break. So where were we? Human extinction. Yeah, so this is a contentious topic, and there's no clear sort of scientific answer of like what is going to happen. There's a lot of uncertainty going on. A lot of things depend on how the AI is designed, and we have the ability to like design it. So why would we make ourselves an AI that was going to kill us? That seems ridiculous. But I think it's still, people are still worried about this, and I think it is still plausible that we could end up in a sort of difficult situation here. So the case that I want to put to you is this. Once artificial superintelligence is deployed, it seems like we wouldn't be able to control it at that point unless it was specifically designed to let us, because I'll explain on the next slide. And misalignment, once an ASI is deployed, it's going to have a transforming effect on the world. And most transformations of the world are not ones that we would survive. So unless it's specifically designed to keep the world survivable for humans, then it won't, and we won't survive. So a little bit more on that. Norbert Wiener, who was also on the reading listing, in fact, I think the paper with this quote is the very short 4-page reading that I invite you to take a look at. It puts it this way: if we use to achieve our purposes a mechanical agency with whose operation we cannot efficiently interfere once we have started it, then we'd better be quite sure that the purpose put into the machine is the purpose which we really desire and not merely a colorful imitation of it. The thing with intelligence is that it's sort of fundamentally difficult to control, and if an intelligent system wants, so to speak, something other than what you want, it's probably going to get what it wants because it can outsmart you, intelligence and so on. Another way of putting this is that for most tasks that you design a system to do, as a part of accomplishing that task, it's going to have certain sort of implied objectives, including to stop anyone from disabling it or changing its task. If you are a superintelligence and you have a task, and then I come along to you and say, hey, actually, I want you to change your task to this other thing, or I want you to stop, you might think to yourself, hang on a second, if I listen to this human, I'm not going to complete my task. My job is to complete my task, so go away. Also, if we sort of try to artificially constrain the capabilities of the system in a way that the system would feel it would do a better job of achieving its task if it wasn't subject to those constraints, then it will probably find a way to disable the constraints. Same for any obvious flaws we put into its design. Thirdly, the more resources it can put towards the pursuit of a task, the more likely it is to be able to achieve the task for most tasks. So unless we specifically design a system to avoid these kind of implications, which is not necessarily something you would think of sort of a priori, but we know about this now, so we could potentially try. But if we accidentally sort of screw up this or miss something else or something like that, we might launch the first ASI ever and then find out that it wasn't quite perfect, and then be powerless to stop it. And so that's called loss of control. And that brings us to the alignment problem. So in my opinion, so far nobody has proposed a design for an AI that will both understand and respect the intentions or values of its designers, let alone those of society. In other words, it's hard to give an AI system a task like, just make things better or something like that, because we have to like program in what is better. Instead, when we're trying to solve this problem, what researchers have discovered is that human values and these related concepts, like humans, for example, what is a human? These are very hard to write a program that specifies what they are. I don't know if I need to do much convincing of you there, because ethics is very complicated, programming is very sort of literal, and most of you have this programming experience, you kind of understand this. Imagine having to write down the utility function of humanity in Python. That sounds, how would you even begin to do that? Maybe we have, what we do in machine learning when in AI, when we can't code something ourselves is we just assemble data and give it to a machine learning system, and then it comes up with the program for us, and it's a bunch of matrix multiplications and so on. So maybe we could learn values from human behavior. But when we have tried this, we've discovered that actually it can be quite difficult to define a sound and robust data stream. By sound, I mean something like the difference between, we want to have something like the difference between likes and value, likes on Facebook or something like that. Human approval is like not a very good proxy for things that actually are valuable or matter, or like are good on reflection or are good to lots of people. Instead, you end up with incentivizing kind of the wrong things that humans will like have a visceral reaction to or something like that. And by robust, I mean something that the machine can't actually like influence in its own favor. So for example, think of if you designed a system that's task was to maximize human approval of its behavior or something like that, and you found a way to do the right version of approval. Well, maybe the AI looks around and one of the options it has is to manipulate the people into thinking that it's great, even if it isn't, or like lie to them or something like this. These behaviors start to become incentivized by this value function, and so that metric is not robust. Even if we manage to define or learn the right value system, it's actually still hard to get the learned AI system to somehow internalize these values. Actually, I've switched here to talking about a learned AI system. So assuming now that we're not only like maybe learning the values, but the system itself has come through some machine learning thing that's similar to current techniques. We don't have precise control over the eventual sort of algorithm, so to speak, that ends up happening on the inside of this black box neural network in this scenario. And maybe it's actually not a perfect reflection. It hasn't learned everything about the objectives that we're trying to train it on. It's learned something that is going to generalize subtly differently, and that could still end us up in disaster. And finally, even if you think you've got all of this right, it's actually very hard to tell, because the more intelligent system you're trying to evaluate, the more ability it has to kind of trick you into thinking that it's doing the right thing. And for example, it's possible to imagine an AI system that sort of has some objective that is not what we intend. It knows that. We don't know it, so we try and test it. We say, okay, what would you do in this situation? But because it can tell that it's a test, it would just tell us what it knows we want to hear, because it actually understands human values. It just doesn't respect them. And because it's intelligent, it would be able to fool us, and then we end up deploying it in the world, and then it's game over. Another sort of technical point here is that actually we have to get this sort of perfect, because any difference in values, when you talk about superintelligence, it's going to completely transform the world in the direction of whatever sort of task we give it. If there's a subtle difference in what we asked for, that transformation might end up being vastly different. And finally, to bring us to extinction, this becomes a possibility even without, you don't have to assume that the AI system hates humans or wants us all dead or something like that. Eliezer Yudkowsky, another sort of famous thinker in this space, has this quote: "The AI does not hate you, nor does it love you. You are made of atoms, and it can use those atoms for something else." Like I said, most changes to the world are going to end up unsurvivable for humanity. If you change things like the chemical composition of the atmosphere or the temperature, we were talking about climate change earlier, for example. These are examples of things that you want to make sure that the AI respects, because if there's something missing in your sort of task that you give it, and it ends up setting that to some wild, extreme value, we might not survive. Okay, maybe actually the alignment problem is solvable, and this is not a big deal. I want to come back to this. But my point is that I haven't seen a proposal that I think can convincingly do this in a way that I'm sort of confident it's going to work out, and that is cause for more research into how to do this. So that is so much for what if society builds a super intelligent AI system. And it's now time for us to begin discussing from a ethical perspective what this means for, whether we should be trying to build an ASI or something like that. But I just gave you guys some kind of controversial and interesting thoughts on the idea that we could all go extinct because of superintelligence. So I just wanted to ask if there are any questions on the last section before. Yes?
I just wanted to ask whether we are far more afraid of AI doing these things than us. Like, as an
Oh,
example,
great question. Yeah, yeah.
like Dr. Strangelove, it came out in the early 60s. It's about like psychopaths and power causing nuclear extinction, right?
Yeah.
Now, that was a time when there were only like 2 countries that had nuclear weapons.
Mm-hmm.
Now, those systems are still in place, and we still can have psychopaths that,
Yeah, we'll definitely talk about this.
but we still accept it, and we've moved ahead down to a world where we can't eradicate nuclear weapons.
Mm-hmm.
So,
Yeah, this is a really good point. So this is one model of human extinction from kind of a rogue AI itself. But it is also possible that, I guess when I was talking about this destructive warfare, I meant to mention, I forgot about this, these destructive capabilities could actually be enabled for individuals. Maybe it's just a small terrorist group in some garage somewhere that's like disgruntled with the world, decides that it would be better off if everyone was dead, and presses a button to ask a superintelligent AI to just do that for them. If they were given such power, that would be a shame. Yeah, we'll talk a little bit about how to, maybe respond to this, but it's a difficult problem. And I don't think that the rogue AI scenario is the only way that we end up with a really bad outcome. One more question, and I want to ask the lady behind. Yeah.
I still have 2 sort of questions.
Okay, sure.
So the first question is, so just from what we talked about, I kind of am confused. Why do we exactly have the urge need, for an AGI? Because from my perspective, it's like a lot of the problems can be solved just with some optimized scenario AI. And
Yeah.
we can just sort of just get rid of all the problems that we just talked about. But why exactly do we?
Yeah, really great question.
Want to build an AGI?
Yeah, so that's your first question to answer this? Yeah, I agree. I think that it might be possible to achieve some of these good outcomes without building anything that is kind of general or human-shaped as an intelligence, which, it's sort of the generality that ends up causing some of these risks. Although I think some of the things that we want to do, the more intelligent, the better, and the more generally intelligent, the better. So that, we might be facing a trade-off there in terms of if we want more effective systems, then we have to sort of take on some more of those risks. But I take your point that, and I think we should certainly, it's a no-brainer as a society to try and achieve these without taking on unnecessary risk, if possible. Second part of your question?
Yeah, so also from all the ideas on how to build an AGI, so I was wondering if there's any other ideas on use the physical cognition, because they're all brain emulation. There's no using a hand to
Oh, yeah.
touch the sand.
Yeah, this is a good point.
Because I think that is pretty important to in human intelligence, the example you mentioned, piece string, because we
Yes.
know from just by touching, we know that is impossible, but a machine doesn't, because it doesn't have a physical hand.
Yeah, great point. Yeah. So to restate the question is something about, this whole brain emulation thing. Isn't that missing sort of physical intelligence? An important part of human cognition is that we're embodied. I think that's basically your point, right? Yeah. I think this is a really good point. And whole brain emulation. So there's 2 answers. One is okay, we could just sort of emulate those things as well. And I think that that is an important. It's not true that the brain is equal with the human's intellect. We've got a whole nervous system goes throughout our entire body, and sort of our experience of the world is mediated through our bodies, and that's sort of a fundamental part of how humans learn and so on. And if you just had a simulated brain without those things, it would be missing something. The second thing is that actually maybe you can sort of get in between. And actually, if you sort of physically think about, there's a point in your neck where all of those signals to your hand and from your hand go through. And if you can find the right interface there, maybe you can kind of achieve the same thing without having actually built an emulated hand or something like that. So this might be possible to sort of sidestep this, but I think it's an important point, and at least it has to be accounted for somehow. Okay, well, let's proceed. Thanks, guys. So, should society build a super-intelligent AI system? So, we're in this situation, let me summarize, where designing and building a super intelligent AI system, I would say it's an ethical dilemma because there are potentially very serious risks, and I've tried to argue that they could be as bad as human extinction, which is pretty bad, so to say the least. If it's possible to avert those risks and get the benefits, that's also something that we definitely want to do. So, you know, we have benefits versus harms. We have to sort of, there's a trade-off here. And something we're not talking about today is like which potential benefits to realize. But that's also another part of this ethical dilemma. To sort of handle this problem, it's lucky that we've been learning all of this moral philosophy, because philosophers, and here we have a super philosopher also known as Immanuel Kant from one of my favorite webcomic series, Existential Comics, which I recommend. Philosophers are people who sort of systematically think about problems and try and do a very good job of thinking carefully, right? And so moral philosophers in particular have developed these ethical frameworks that give us principles that we can try and apply to help us make the right decision when we're facing dilemmas, where there's sort of a trade-off, we have to find the right balance. Ethics can, in principle, help. It's not necessarily going to actually swoop in and save the day completely because, you know, not even moral philosophers agree about everything. And there are some questions we might be able to bring to them they won't have a unified sort of consensus answer for. We'll have to sort of work on the philosophy as well. But at the very least, using the frameworks we've learned, we can try and unpack this question of should we build ASI and see if we can make some progress. I'm thinking clearly about this. So first step unpacking it is, should society build a super intelligent agent is not quite, oh sorry, that's a typo. I should have changed this. It's not about agents. I should have changed it to super intelligent AI system. This is not a precise enough question because society isn't usually considered to be a moral decision maker. Normally we talk about individual people as moral decision makers. The term in philosophy for this is moral agent. Moral agents are beings for whom it could be right or wrong to do something like contribute to or build or press the button that says deploy on a design for an artificial superintelligence. So there are various possible moral agents we could consider in this case, including the individual executives leading companies that build AI or politicians leading future national efforts to build AI systems. Maybe the individual researchers and engineers that make up the efforts to build these systems. Perhaps the voters or investors that kind of direct, you know, in principle steer these decisions of these companies, public companies and democratic governments. It is possible to have an ethics of the sort of morality of actions from the perspective of a collective, such as a corporation or a country or all of humanity. But this is something that is not sort of the standard in philosophy, and so we would need to study that kind of, when does that make sense, and what do we do with the answer? Like, who do we tell, okay, humanity should do this? But, you know, we could potentially go down that route. But for now, I think we should sort of think, when I say should society build a superintelligence, we should think about, for example, you're an individual facing the button that says deploy or don't deploy or something like that. And there are slightly different moral questions than if you're also like a contributor to the project and so on. Secondly, we need to think, as a first step to answering this question, who are we actually going to consider the effects on? Moral patients are the beings eligible for moral consideration by the moral agent. And so here are some candidate moral patients, although this is also an area where philosophy has some work to do to sort of clear up where we're going to draw the line. This might seem a little bit silly, but you might think that, okay, all customers of a corporation or all citizens of a state are the moral patients. This seems a little bit silly in modern times because we mostly talk about like a global perspective on the world, but actually, you know, you could think of a nation or a corporation as having like a duty of care for its, you know, people that comprise it. And so maybe this isn't super silly, but at least, you know, this is something that's going to affect the entire world. So maybe we should be thinking about all living humans as the moral patients of the action. If we're going to transform a world, well, it's their world too. You know, just because they're not Australians or just because they're not members of the University of Melbourne doesn't mean that they don't get a say. It's a much more modern kind of take, and I think it makes sense in this case because we're talking about global effects. Okay, some more uncertain ones, although recently sort of there's been trends in thinking about non-human animals and the environment, planet Earth itself, as potentially beings that have their own moral significance. Now, of course, when I think about something like the environment or animals, there's a pragmatic incentive for humans to value them because that will help humans. Like, if we don't have a planet Earth, then we can't live, so we need to value the Earth. But I'm talking about intrinsically valuing these things. In the case of ASI, this is like not necessarily such a big deal, but in the case of talking about extinction, well, probably if humans go extinct, then all of the other mammals are going to as well, and potentially all of the other life on Earth. Maybe the entire planet will be turned into a steaming pile of a computer. And so, maybe that's bad in its own terms. Okay, here's another one. What about past humans and or future humans? Past humans, we can't really give them any pleasure or pain or anything, but there's some sense in which they've set up this story for us. Our ancestors have sort of created the world. Are we just going to say thanks to them by destroying it? That, maybe there's an ethical sort of dimension to that, and that could cause us to sort of think about their dignity and the continuation of their story. Very quick question.
Well, statement. Tupac Shakur has rights to his personality even if he's dead, and Drake comes along and decides to synthesize Tupac's voice into his diss track against Kendrick Lamar. This happened like 2-3 weeks ago.
Interesting.
It's actually quite a good point. Do you have the right to generate speech of a dead person?
Yeah. In this case, I'm more. That's a good point. I'm more focusing on the idea that throwing away what our ancestors sort of worked so hard to build this world for us, and then destroying it is in some sense wrong, even if they aren't around to say so. But I think it's similar sort of point we're making here. Future humans is another one. In one sense, everything is at stake. If humanity goes extinct, then the potential billions and trillions of humans that might exist in the future don't even get to live. So we've taken everything from them. But in another sense, we've taken nothing from them because they don't live. So what do they care? This is a pretty thorny philosophical area called population ethics that sort of talks about questions like, can you wrong someone who, if as a result of your action, doesn't come to exist, for example? And that's a pretty tricky question, and philosophers are sort of struggling with this one. It's my impression. And of course, if we're talking about particularly intelligent AI systems, maybe they even get a say. Maybe they even should be counted as moral patients. And this is when we tie back to something like consciousness. Maybe that's the crucial determining factor over whether or not this should be the case. But this is something that philosophers, I think, have some work to do to come up with an answer here as to under what conditions we should consider the AIs. It certainly matters, for example, if AIs are actually going to be benefited more by humans going extinct in a moral sense, then maybe that's actually the right thing to do. As funny as it seems to say that. So this could make a big difference to the outcome of our moral deliberation. For now, I'm going to focus on all living humans because that's something we have immediate sort of intuitive access to, and we don't have to worry about the rest of this sort of unsolved philosophy. But this is something that really matters and could change the considerations here. So I'm not dismissing it because it doesn't matter. I'm dismissing it because we only have the remaining time in this lecture, 25 minutes. Okay, let's go through the frameworks. Utilitarianism, super easy. What are the consequences? There's some probability that we could have lots of positive utility if we build superintelligence. There's also some probability we could have lots of negative utility if we build superintelligence. The principle of utility says we've got to quantify that probability. We've got to figure out how much utility that is, what's the magnitude. We just add up, get the net value. If it's positive, we build the ASI. If it's negative, we don't. Easy. It's a little bit more complicated, of course, because while in this course we've often been analyzing decisions from the perspective of do we build this system or do we not? It's a binary choice. Actually, in reality, of course, utilitarianism says we have many actions and we have to choose the one that maximizes the expected utility. And in this case, the probabilities and the size of these utilities depends heavily on how the system is designed. And also, our knowledge of those probabilities depends on what actions we take to sort of improve that knowledge. So for example, doing research is an action that might, if that research informs us as to the actual utility and probabilities involved in the calculation, gives us a more accurate estimate of that, and then that would affect which choice we make. Maybe the action that leads to the most utility is to stop and research, get better estimates, and then make a decision, rather than immediately making a decision about which ASI design to go with. So I think the conclusion from utilitarianism, while it's not very insightful, it's kind of maybe what we would have come up with anyway, is we should pursue research as well as development, aiming to maximize the expected utility, and that means identifying and avoiding the risk where possible to minimize that probability of negative utility and maximize the probability of positive utility. But one thing about utilitarianism that we can draw is that at least we know how to make a trade-off when there is positive and negative probabilities at play, or probability of positive and negative utilities at play, and that is that we just add them up. We use this principle of utility. Maybe other frameworks will have something different to say about that. So here's deontology. Deontology is about duties. We should take an action if it accords basically with the important moral duties, and we shouldn't take it if it doesn't. So some of the duties we've studied this semester that apply here, in my opinion, are Ross's duty of beneficence, which says we should take actions that promote the well-being of others, and Ross's duty of non-maleficence, which says we should avoid harming others. Okay, these are kind of in conflict because if we take a risky decision that might end up harming people, but otherwise might end up benefiting people, that's kind of, either way is going to be going against one of these duties. If we take the risk, then we'll be going along with the duty to promote the well-being of others, but violating the duty to avoid harm, and vice versa, if we don't take the risk, if we don't try to build the system, we'll be violating the duty that we had to benefit people, even though we're meeting the duty to avoid harming. Okay, Kant's formula of humanity also says that roughly, there's the sort of precise version, but the rough version is we've got to respect other people's autonomy. So I put these together and thought, well, okay, let's say we have what looks like potentially a good bet in the utilitarianism perspective. We have a positive probability on net of it going well. Positive utility sort of in expectation of it going well. Maybe we shouldn't unilaterally endanger the rest of humanity as the board of a particular AI corporation or something like that. Because that doesn't really seem like it would be consistent with respecting people's autonomy to determine like their own future and so on. If we just sort of make a decision for them to take this risk. Maybe they should have some say in that risk, and that would be respecting of their autonomy. This is sort of like a consent issue. As for this duty thing, I think maybe you can make a case that Ross would say that that even if it's a good bet, maybe that's not quite the right way to think about it in terms of like probabilities. 50-50 chance that, or let's say it was a 51-49% bet that this was going to be the greatest thing or the worst thing ever. Just because it's positive on net doesn't mean that it's a good idea. Maybe the duty sort of says that that's not quite the right risk sensitivity level to adopt. And finally, virtue ethics. Okay, so I find this one much harder, as I'm sure some of you also do writing the essays these days, but here's what I came up with. Virtue ethicists invite us, sorry for the typo, to consider a character-based perspective on how to approach the design of artificial superintelligence. And this is maybe tipping my hand a little bit, as in I believe that these risks are serious, and so I'm going to think that it's virtuous to take actions such as believing that the risks are serious. Maybe it's sort of too soon to tell what was like the right thing to do here, because virtue ethics is sort of also about are your actions effective? Like you've got this sort of practical wisdom element that you have to actually sort of make the right decision in hindsight or something like that. But let me offer you this. Here we have Norbert Wiener. We saw the quote from Wiener earlier. Norbert Wiener was not so much involved in the history of AI. Sorry, that's completely wrong. He was father of cybernetics, the research field that sort of is a precursor to modern ideas in AI, such as reinforcement learning and just a whole lot of other contributions to mathematics and science. But his main fame, what I meant to say, was in his kind of political sort of handling of his research having military uses. And he was a very strong and kind of publicly advocating his actions, boycotting applications of his research to military uses, such as nuclear technology. So, for example, there's this story where a scientist writes a letter to Vina and says, hey, can you send me that paper that you published that's your work that, I can't find it online or like in the library or whatever, it's out of print. I don't think online was how it worked back then. And Vina says, hang on a second. If I send you this, you're going to do military research, research with military applications, and therefore I'm kind of complicit in that. And he just said, no, I'm not going to send it to you. And then he published his reply, his letter, in a journal to sort of call out people who did military research. So I think what the virtue that Vina sort of stands for here, is what I'm trying to get at, is that you should take, even as a scholar, where you're confined to your laboratory or your academy, you should take the real-world applications and implications of your work very seriously. And Vina very strongly embodied this character trait, and even generalized it at a certain point to sort of boycotting research that had automation applications, not just military applications, but like displacing workers, for example. He was like, well, hang on, I don't want to be a part of that. And then was worried about automation and eventually risks from out-of-control AI, and so that's where we ended up with that quote from earlier. So you should pay attention to the societal impacts of your work, even if you're a scholar. You don't get to just wash your hands of that. That's the virtue that Vina teaches us. Yoshua Bengio and Geoffrey Hinton are two of these sort of founding fathers of the deep learning revolution. And over the last few years, they've kind of, off getting all of this fame and power and leadership sort of credentials in their field of AI for their contributions, which have been astounding and sort of really helped us get to this point we're at. They sort of thought, well, hang on a second. If this all causes massive harms to society, including up to human extinction, that's not what we wanted at the start. And I think that this has displayed the kind of important character trait of following through, looking for the benefits. It would have been easy for them to kind of shut their eyes to this. They've like established themselves as researchers. Geoffrey Hinton had a position at Google as like a vice president of research there. And he's like, okay, I'm actually going to leave this position at Google because I'm no longer on board with the way this is going. And I think that we need to take a different direction. I think this was a hard decision, and I think it showed strength of character. They're following their sort of motivations to actually benefit society rather than just sort of like do work and get sort of status and stuff like that. And finally, we have Helen Toner here. So if you guys follow along with some of the drama last year regarding Sam Altman's brief ouster from OpenAI, Helen Toner was a former board member and was part of that sort of decision-making process to fire Altman. Eventually, as you will know, Sam Altman is back as CEO and Helen Toner is out of the board. Helen Toner was one of many people that was sort of a part of this fight. But just as one example, she shows that there are lots of incentives and market forces that are sort of pushing for AI, potentially at the expense of benefits to humanity. And OpenAI has this weird structure where there's this non-profit, which Helen Toner was a part of, and then there's the for-profit sort of OpenAI sitting underneath that. And the for-profit is the one, actually there's also like a cap profit, it's very complicated, but this sort of is like the market-driven one with investors and stuff like that. And Helen Toner was part of the non-profit that's supposed to keep it accountable and say, well, if you guys are straying from the mission of benefiting humanity, then that's not what we set out to do. We have a responsibility here. And so she was part of the team that took that fight to Altman and ended up basically losing that fight, but at least showing that these forces, these economic forces are very powerful and need to be taken seriously. And we could end up in a situation where if it's going to make enough people money, they're going to sell out the human race. And Helen Toner is an example of someone who is working hard to fight against that.
Interesting side note. She's actually a University of Melbourne alumna.
I was going to say this, yes.
So you can get fired from the Silicon Valley.
That's right, yeah. Helen Toner graduated from the University of Melbourne 10 years ago, and since then she's been working in strategy and policy around impacts of AI in society. And yeah, this is a good and motivating example, I think, relevant to us here. Okay. we have one more question, and okay, question. It's important to
It's not actually a very
make it quick then.
It's just a quick one. So like for the utilitarianism,
Mm-hmm.
so most people like what if most people die out because of AGI, and then there's going to be a huge amount of negative utility, but then a small amount of humans survive with a very high individual utility, and then with enough
Good question.
time, the utility score gets bigger or gets equal to like all humans survive.
Yeah, great question.
What's your position?
Yeah, so what if in order to access this future very positive utility, actually, humanity, most of us have to be extinct and suffer that negative utility. If that was really the case, then utilitarianism pretty straightforwardly says that that's what we should do, which is a bit of a weird conclusion, I think. Yeah, so the question I think is that actually the case, and could we actually know it in order to justify that, use that to justify our action? I won't take a follow-up question. Got to move on. Thanks for the question. Okay, will society build a super intelligent AI system? So more about sort of the current politics and sort of economic landscape here. So very quickly, there are lots of incentives for automating intelligence, economic incentives. So basically, you can make a lot of money from this. So corporations feel this incentive, nations and their leaders feel this incentive, also other incentives such as military incentives, sort of to stay competitive in modern warfare. If your enemies are going to be using AI-enabled warfare, then you kind of need to be too from a defense and sovereignty perspective. Sovereignty also includes like data sovereignty. If your citizens are going to be reliant on AI technology that is imported, then you're sort of losing control of that, and that can open you up to issues as a sovereign nation. So this is an issue that nations feel. The rest of these actors, mainly it's the market incentives. So investors, obviously, there's lots of money to be made by investing in AI companies that are successful, and individual researchers and engineers get compensated very handsomely for work in this area because there's so much money to be made by the investors in the companies. But also there's this sort of spirit of invention. As a young AI researcher, you might have very grand ambitions of like, solving intelligence. That's a very grand challenge, and so that also draws people into this field. So, things are kind of pushing for AI to be built continue to advance. That's the point of that other slide. So we end up with this thing called the unilateralist's curse, and there was a brief sort of touched on this a little bit earlier with a question. We talked about how maybe there could be like a situation where actually the decision to put people at risk is a calculated decision. And maybe if you think there's some chance that your design is going to end the world, but that chance is sufficiently low, and the benefits are sufficiently large if it does work, then maybe you actually think it's a good idea to make that bet. Because you think your approach is like going to do a good job of keeping that extinction probability low, so you're happy to sort of gamble. There's this thing called the optimizer's curse in statistics, where if you sort of sample many times from a distribution and take the maximum, it's going to be wildly out of distribution. In this case, we can apply that intuition as follows. If there's a large number of groups that are facing this calculated risk decision, there's naturally going to be a distribution of their risk tolerances and how optimistic they are about their approach. And so the one that is actually going to take the approach is going to be the one that it sort of looks like a good deal to, but while being like wildly miscalibrated, because they will be like wildly overconfident in their safety approach, and they'll be wildly high in their risk tolerance, like there'll be some freak risk taker or something like that. Like not cognizant of the importance of this decision and like the risk to the rest of humanity and how serious that is. So the unilateralist curse is that basically this is going to end up with this decision being taken much more likely than like if we just assumed that everyone was equally reasonable about things, because it's going to be taken by the person who is the least reasonable about it, and they would be a unilateral actor. Unilateral just means acting alone. So we could end up in a situation where, this is one more thing before I get to like the summary of that, is that there's a race dynamic. So let me ask you a question, a thought experiment. Suppose you are the leader of an AI research corporation, and you have an ASI design, and you have an AI safety team as a part of your organization, and they come to you and they say, actually, I'm sorry, there's an unacceptably high risk of severe misalignment if we deploy this system. You have several choices about how to respond before you build your ASI. You could wait until your safety team has a solution. I don't know how long that's going to take, maybe a year, maybe 100 years, who knows. Just you could give them more time. You could say, all right, well, I'm going to give you 6 months, and if you come up with whatever you come up with in 6 months, we'll put that in and then we'll go. Or maybe you just ignore your safety team and you say, I never should have hired you anyway, you fire them and you deploy the ASI as is. So the question is, what should you do? Or, you know, maybe what would someone in this situation do? Different questions, but hands up if you'd wait until your safety team has a solution. Okay, a couple of people. Hands up if you would give them 6 months. A few people as well, roughly the same number. Hands up if you fire them and just go straight ahead. This is all silly anyway. Actually, at least one person put up their hand up. I'm a little bit worried. Okay. The follow-up question is what makes this interesting. Does it change your answer if you additionally know that your main competitor, who doesn't have a safety team and is openly dismissive of the risks, they're only 6 months behind you. And so the maximum you can wait is 6 months. Otherwise, what's going to happen is they're going to probably deploy their ASI. Everyone's going to be dead anyway, or like at least as likely as your design is to kill everyone. And so in order to have the maximum chance of a good outcome, maybe it makes sense to take a larger risk because of this pressure that someone behind you is going to take a worse bet if you wait. That's the race dynamic. And that's another worrying aspect of this. So in economics or game theory, you might call this a tragic situation where even though no one wants the outcome of deploying an unsafe or like not necessarily safe or like taking a big risk on an ASI, we could end up with that situation happening anyway because of individual sort of incentives and like distributions of beliefs and so on. The only way to solve a tragedy like this in game theory is to coordinate. So for example, you can try and dampen the incentives by, well, I'm not a policymaker, so I won't make suggestions for how you might do that, but you could try and use governments to introduce regulations and so on to reduce these incentives. And maybe you can go as far as to actually prevent unilateral action, like make it that you have to register before you're allowed to do this kind of research and like very strictly enforce that. And so two approaches is this idea called AI governance, where you have regulations that try to stop people from taking these kind of risks, individuals or actually also nations, if you had some kind of international agreements, like nuclear non-proliferation treaties would be an example. Also, on the theme of nuclear, as a similar example of something that, you know, we're all familiar with this idea of mutually assured destruction, how the threat of retaliation from a nuclear power is enough to destroy you if you strike with a nuclear weapon. So it's not a good idea to even consider it. With ASI risk, we have this idea of self-assured destruction that, you know, not even a unilateralist wants to die, except for, you know, maybe there are actually individual examples, but most corporations are doing this for money, not because they want to actually die. So it's a no-brainer, just like don't build a system that is going to kill you. And so if you had a better understanding of that risk and that understanding was accurate, like when it was riskier versus safe to deploy such a system, and then maybe we wouldn't have to worry about these risks because people would just not be stupid about it, although we still have the problem of bad actors in that case. So my final point is that actually this coordination seems like a great solution and we should pursue it, but coordination comes with costs, and so this leads us to a further dilemma. Some examples of this are how, if you want to prevent misuse, then that suggests closing off access to all of your technology. And safeguards, if you open source your technology, the problem is the safeguards can easily be removed, and then other people can sort of do things that you wouldn't have done and still lead to bad outcomes. Non-proliferation, another typo, that is basically the same as saying we should just, keep the people who currently have AI or currently have power. They should be the ones that are allowed to have this power, and everyone else, sorry, it's not safe. And so that's concentration of power, an existing kind of problem that we have in the world that this would be going to sort of make even worse. If we have arduous regulation, similarly, that's going to make it hard for new developers to contribute to the space, and that's going to reduce inclusivity of the people who are actually designing these AI systems and sort of cap it at the level that we have at the moment, which is not very inclusive. And if you want to actually defeat the unilateralist curse, you kind of need to stop everyone from doing things that they might want to do. It means you need pervasive surveillance and restrictions of freedom. Sounds awful. And this reminds me of this concept from economics called bootleggers and Baptists. I don't know if I have time to explain the analogy, but the situation is that this actually sounds like a great business strategy for an AI company. If you want to keep your kind of advantage over the competition, you just sort of make it so that, try and make it clear that safety is something to be really worried about. You talk to the governments about this, you get regulation, and that sort of crushes your competition. And here I am sitting in front of you and saying, this is a real problem society needs to face. And the last thing I want to do is be like setting up this PR case for Sam Altman to be able to go, as an example, hypothetical example, to be able to go to Washington and be like, AI safety matters, we need regulation so that we can stay on top. I mean, what? Yeah, I'm like the opposite of move fast and break everything philosophy. Here I am at university several years after graduating from an undergrad in software engineering without ever having had a real job. This is not me. So the way I think about this is that we also have to keep in mind that these companies are not necessarily on the side of safety. We have to make sure that they're doing the right thing as well. And that makes this coordination and all of this sort of stuff, finding an ethical path forward in the development of superintelligence, much harder than it otherwise would be. So, I have 1 more minute, so I'm going to tell you about this. I would characterize the current public discussion as follows. There's these 4 camps. There's probably more, but this is what I could think of. There's the AI safetyists, a bit like me, concerned about risk from future AI systems, although I'm also concerned about risk from present-day AI systems, and I'm trying to articulate to you that there's this tension between those two things. In the example of like open source versus closed source, for example. Open source could do a lot to help with modern issues in AI ethics, but it also could make future issues worse. And so there's this tension between these two camps of AI safety and AI ethics who are concerned about risks from the present-day AI systems. There's the other camps called the accelerationists. So for example, the humanist accelerationists say, actually the risks aren't a big deal. We should, it's like this benefits that we could have are actually compelling. We should definitely race as fast as possible to get those. Actually, sort of, even if we have to tolerate some rising inequality, it would be good because the people that are worse off are eventually going to be better off because everyone will be better off, kind of story. At least these people are on the side of humanity. And then there's the post-human accelerationists who pursue the advancement of intelligence itself. It doesn't matter if humans survive because something will replace us and that thing will have value. I mean, maybe that's true, but I don't know. That's at least a harder case to make. So perhaps surprisingly, these people, the accelerationists, are totally in agreement of what we should do right now. And so they work together and they take over Silicon Valley and they sort of behind a lot of the push here. Perhaps surprisingly, there's this bitter rivalry between these two. I guess that's not so surprising, like I said. It comes down to this sort of difficult problem of like solving one problem is going to make the other worse, and so we need to find a way to solve both problems without making either worse, and that's difficult. At least, if we had better beliefs about the actual risks, I think these first 3 camps would agree, whereas these last 2, these would disagree because they have fundamentally different values. The values of humans versus whatever comes next. And so, maybe if we could do research on AI safety, find out like how much of a problem this sort of thing is likely to be, what we can do to actually mitigate the risks, is it possible to completely avoid them, then everyone here is probably going to come onto the same team. If the accelerationists were not able to be as dismissive of the risks, then they'd have to tamp down on the brakes. So that's all. So we started with 4 questions. Can, what if, and should, and will society build a superintelligent AI system? And my conclusion is, it seems plausible we can. There may be unforeseen barriers. We haven't talked about timelines. Those are even more unclear. What if society builds superintelligent AI systems? It could completely transform society. That could be good, that could be bad. Plausible, but not certain that we could be heading for an outcome as bad as human extinction if we don't try very hard to avoid that. It seems a little bit harder to avoid when we look into it. Should society build a superintelligent AI system? Yes. In fact, we must do so because these benefits are compelling. But only if we can avoid the risks. Otherwise, it gets more complicated. And we need to do this without compromising ethics in the meantime. Otherwise, that's going to say that it wasn't worth it either. And we haven't talked about this, but we need to, decide what to do with the superintelligent power in an inclusive manner and so on. As for will society build a superintelligent AI system, we're apparently racing towards this goal about as fast as possible right now as a society. Slowing down, not to mention stopping, would require solving a very difficult coordination problem, raising its own dilemmas. So that's all. Thank you.